Hello everyone, welcome to our 3D print webinar today. My name is Anita Anand. I'm the VP of Sales at Mexsoft Corporation. I have here with me Uday, our support manager, who will be running the session. Also with us is Joe Anand, our product manager, who will be available to answer questions during or after the presentation. Now, in today's presentation, Uday will be talking about our additive manufacturing or 3D printing software solutions, which really offers efficient, easy, and automatic tools for the preparation of 3D data. He will demonstrate working with the point clouds and meshes, and as you can see up on your screen, he will show you working with those point clouds. He will show you the mesh data, how you can repair it, model modifications, and in our new 2016 version, we have added a lot of new mesh repair and modeling features that Uday is going to key in on for you. He will also show you some other features like the print volume, check and export, and especially the part orientation support generation, which is brand new and has been requested from our users. And the big one is also the G-code output. So Uday will be touching on all those topics, so we have plenty to touch on today. Now we offer the software solution as a standalone product called the Visual 3D Print. It comes with our Visual CAD modeler. We also offer the same solution completely integrated with Rhino, and therefore you have the Rhino tools that you could use alongside with our Rhino 3D print tools that we provide. Now, some quick tips before we start our presentation here. You have it on the screen. You can use your chat window for questions. Apart from that, which we would try to answer during the presentation, but then we will leave a few minutes at the end of the presentation to answer your questions as well. The webinar is being recorded, and we will make this available on our website. We will send you an email as soon as that's uploaded, so you can access it at your leisure. At this point, I will let Uday take over and get started with the more important and fun stuff for today.
Thank you, Anita. Good morning, good afternoon, good evening, folks, and thank you for joining us for today's webinar on our 3D print product. This is our additive manufacturing solution in the suite of CAM products Mexsoft offers. Today, I'll be going over all of the nice features that are offered in our 3D print product, and I'll also show you what's new coming in the 2016 version of our 3D print product. Now, without any further delay, I'm going to go in and jump directly into our plugin for Rhino, which is the Rhino 3D print. Now, all of the features that you see in the 3D print module that is offered in Rhino 3D print are also available in our Visual 3D print product as well. Now, what I have here currently on my screen is a 3D model that's designed in Rhinoceros, or it could have been imported into Rhinoceros as a solid surface or a mesh geometry. Now, the part that was modeled here was not intended initially to be 3D printed. So let's take a look at how we can make it suitable for 3D printing. Now, once you have Rhinoceros loaded and Rhino 3D print installed, you will notice right at the top of your screen there's a Rhino 3D print menu appears at the top. Now, selecting this menu at the top gives you a pull-down menu of options, and when you click on Welcome, this gives you access to the data sheets, quick start guide, your online help, and web resources. So we're going to click on Rhino 3D print and then select Browser. This displays your Rhino 3D print browser interface in Rhinoceros. The browser by default is docked over to the left side of the screen. You could actually have it floating or docked to any location in your Rhinoceros application interface. Now, the browser offers 5 main tabs. You have the Create tab, which offers creating tools. You have the mesh primitive modeling tools. You could create mesh from point clouds. You can convert solid surface to mesh geometries. The Model tab offers you powerful Boolean tools like Boolean unite, subtract, intersection. We've also introduced intersection and split in the 2016 version. And we have split and offset and hold tools as well as slicing. So the offset and split would result in a shell which can be used for your 3D printing applications. Now the Inspect and Modify tab offers analysis tools where you can perform reflection line analysis, curvature, you can compare two meshes, mesh modification tools like mesh reduction, remeshing, mesh smoothing, and 2016 version also introduces mesh manipulation where you can individually select areas of the mesh to manipulate it. And as we go through today's webinar, we'll try to touch upon all these topics. The Repair tab offers a powerful set of mesh repair tools starting with Stitch and Close. AutoFix can be used to automatically fix holes, self-intersection, and incorrectly oriented triangles. We are introducing Manual Fix in the 2016 version where you can manually fix holes using different options for fixing the holes and perform a diagnostic check to check for open edges and other issues on a mesh geometry, and you have options to separate, fix, and flip orientation of mesh. Finally, the 3D Print tab offers build preparation. This is something new that's being offered in 2016. You can have the orientation of the mesh determined based on the minimum bounding box or based on the minimum overhangs. You also have support generation tools where you can build supports before printing the mesh. And then you can select your printer, fit the mesh to the printer's volume, perform checks. You can either export it as STL, SLA, AMF, or you could generate G-code and have it sent out to the printer. So we'll try to go through all of these different features in our 3D print module. Now the same set of features are also available in our Visual 3D Print product, and it's greatly accessible from the 3D print browser. Now what I have here is a solid model that was built in Rhino, and this part actually has some moving parts or rotating parts as well. So to be able to print this, I'm going to actually have to mesh them separately. So for now, I'm going to go ahead and hide the moving parts. I have them on a separate layer. Now this is basically a solid geometry or a poly surfaces. And first thing I'm going to do in Rhino is look for open edges. There's a feature called Show Edges where you can actually select the model. Then when you look for open edges, or Rhino calls it naked edges, you'll see that there are several open edges. So just converting this to a model from a poly surface or surface to mesh is not going to make us and be able to print the model out. So one of the things I'm going to do first is, to fix these, open edges on a poly surface, it's going to be a time-consuming process, and then converting it to a mesh. First step I'm going to do is convert this to a mesh. Now you can convert it using the 3D Print Convert tool in here, or you can use the native Rhino tool if you prefer. You can go from mesh from NURBS object, and you basically select all of your geometries, and then you use the mesh options in here to create a mesh. So let's go ahead and click OK. And you will now notice that once the mesh is created, the data tree in the 3D print browser will list all of the mesh geometries. So we currently have 26 meshes that's created from this geometry. So I'm going to select these meshes and just have them on a separate layer in Rhino. And I will go ahead and turn off the polysurface geometry in here. So we got all of these meshes. Now let's go to the Repair tab and run a diagnostic check on this mesh to determine the number of open edges. So I'm going to select the mesh and press enter. Now what I'm looking for is open edges, and I'm going to run some checks. Now you'll notice that the open edges have been identified, and they've been basically they're showing up on the model marked in red right there. Now to manually fix all of these meshes, it's going to be a time-consuming process. So we have a very powerful tool in here called AutoFix. So I'm going to use this AutoFix tool, which automatically looks for holes, self-intersections, and any incorrectly oriented triangles, and will automatically fix the mesh. You notice that the AutoFix ran, and it automatically fixed all of the meshes. Now you'll notice that there are several of these closed meshes on the model. So if you need to print this as one single geometry, we need to merge them or unite them to a closed mesh. So I'm going to go to the Model tab and use the Unite tool, and I'm going to merge all of these meshes into one closed mesh. So now the Unite process resulted in one mesh, and you can see it has close to 180,000 triangles on it. Now let's go back and perform a diagnostic on it to make sure all of the meshes are closed in here and see if there are any open edges. So when I run a check, I'm notified that there were no issues detected, which means the mesh is closed. That's great. Now let's take a look at what are the other nice features that we offer in Rhino 3D Print. Now before you want to print this part, you may want to insert some battery packs, so you may want to have some wall thickness. So one of the ways to create a wall thickness is using a process called offset mesh. So if you go over to the model tab, you'll see the feature called offset mesh. So I'm going to use the offset mesh tool and select the mesh to offset. And the offset parameters in the dialog below allows you to specify your offset distance and a tolerance to offset. Now specifying a negative offset distance and offsetting the mesh will offset the mesh towards the inside, which means it's going to make the resulting mesh smaller than the original mesh. If you specify a positive offset value, it's going to basically make the mesh larger. So you can see that we now have two meshes in the data tree in here. You have your original mesh and you have the offset mesh that's inside. So I'm going to toggle the visibility of these mesh in the tree so I can see the two meshes. Now one of the nice features that Rhino offers you to view the model is you can actually insert a clipping plane in here, and you can take a look at the the two meshes that are created by inserting a clipping plane. So I'm going to go into the visibility tab and quickly add a clipping plane in Rhino from one of the side views. And I'm going to select this clipping plane and I'm going to enable that. So you'll now notice that when you take a closer look at the model, you can see how well the offset is performed, and you can see that the offset has a uniform offset for the offset distance we put in there. So take a look at that. Such a complex model and has a very nice offset on it. Now the next step I'm going to do here is I would like to split the mesh, split the two meshes, the original mesh and the offset mesh, and I would also like to have this gap closed, or I want to cap the gaps between the two. So here's how I'm going to do it. So first let me go ahead and disable the clipping plane in here, and I'm also going to go ahead and disable it from the front view, and I'll hide the clipping plane. Now we have a powerful split command that's built into the model tab. I'm going to use the split command, and the split basically works in the view that you're currently active on. The splitting plane will be parallel to your active construction plane, and I'm going to select the two meshes to be split, and then when I select the command, I'm given an option to pick the bounding box where I want to split. By default, it'll use the midpoint of the bounding box, so I want to split it right in the center as you see it. And we have two options, whether you want to cap the results after you split it or do not cap it. So in this particular case, I would like to cap it, and I'm going to select split. Now one of the things I would like to point out here is the splitting process could take anywhere from a few seconds to several minutes as it goes through a complex process of splitting the mesh. Now while we are waiting for the mesh splitting process to be completed in here, what I'm going to do is show you some of the other powerful tools that are offered in our Rhino 3D Print products. So I'm going to go ahead and switch over to another session of Rhino, and I will get back to the part once the splitting process is complete. We'll go back and check on it in a moment. Now one of the nice tools I want to show you that we have introduced in the 2016 version is how to manually fix meshes. So I'm going to go ahead and bring in an example in here, and as you can see here I have a mesh model, and if I go ahead and perform a diagnostic on the model in here, you will notice that there are several open edges on it. Now performing an auto fix will basically just close these meshes, but that's not how you may want to be fixing the holes. So we have added a tool called manual hole fix, where you can actually detect the holes and you can choose what type of fix you would like to apply for it. Now for example, when I select the hole in the list in here, it highlights the edge where there's an O hole, and you can choose what type of fixing you would like to perform. If you select the fix type as fan and preview the fix, it shows the resulting mesh that's going to be added after it's fixed. In this particular case, I could choose planar, and you can see the result of the planar fix. Now the ideal option would be here to use a smooth fix. When I preview the fix, you can see that the mesh actually follows the holes that are being fixed, follows the kind of the wavy surface on the mesh that you see right there. So I'm going to hit preview and then apply fix, and you'll notice that this is a very powerful and handy tool where you can pick areas, pick certain holes and fix them the way you need it. So this is one of the new features that are being added in the 2016 version of our 3D print module. Now let's go back and take a look at it to see if our splitting mesh was done. There you go, it was done. So let me go ahead and take a look at the mesh, result of the mesh right here. And now we can see that the splitting process did split the two meshes, and it capped the result. So which means it capped the gap, so you have a wall thickness in here. Now the part is ready for 3D printing. Now if you want to go ahead and print this part, you would want to first make sure you select your printer in here. So you can go to the 3D print tab, you pick a printer, and we have a list of printers that you can select from. Newer printers can be added to a list. There's an XML file in the install folder where you can go ahead and add new printers, and if you need any help with that, feel free to contact us and we can help you out with that. Once you select the printer, you can also specify, if the printer reads G code, you can specify the nozzle diameter of your printer and save the information. And in this particular process, I'm just going to close it and then display my printer's volume. So once you have the printer's volume displayed, in this particular case, I need to orient the part, so I can use the Gumball or any Rhino's transformation tools to rotate the part. So once the part is rotated, I could then use the fit option in here to fit this model into the printer's volume. Select the model, and then I can choose the alignment option. For the Z, I would like to place it to the bottom and then have it centered in X and Y, and I can pick fit. Now once it's fit, I can go ahead and perform a check to see if the mesh is closed. I can run a check, and if there are open edges, you'll be notified of open edges saying mesh is not closed in here. You can see that the mesh is not closed, so I can go back and do an auto fix on it to close this mesh. And then I can go back and check and then export out as STL, SLA, or AMF to a printer. We'll talk about the G code in just a few minutes. So this would be a typical workflow of how you would fix the mesh, how you would orient it, how you'd have it aligned, and then finally you want to do an export where you can export out as an STL, SLA, or AMF, or we'll talk about the G code generation in just a few minutes. Okay, so this would be one of the applications where you would be starting out with a solid surface geometry and convert it into a mesh geometry and fix all the errors and issues that you find in the mesh, and perform offset and split to get the model prepared for 3D printing. Now let's take a look at an example where we would like to work off a scan data. So I'm going to go ahead and import in a scan data. So I have a scan data model here, and this particular model is in ASC format. So the spacing or the delimiter is a space. So the way the file is basically saved, the data is saved in the scan file, and the point cloud file is by spaces. Now you can see that as I loaded the point cloud data here, the point cloud information appears in your data tree, and selecting this in the data tree displays the total number of points that are in this particular model. So you got close to 500,000 points on it. Now with just these points, you'll not be able to output these points out to your 3D printer. So you need to basically go through the process of creating a mesh from the point data. So we have a very nice tool called Mesh from Point Cloud. So we're going to select this, select the mesh, and press enter. Now you can specify the options for creating the mesh. I'm just going to go with these default parameters in here and select create. So in this process, a mesh is created from the point data. So once the mesh is created, the mesh automatically would appear in your data tree under meshes, and you can take a look at the mesh that was created and then see if the mesh is ready for printing. Now you can see that the mesh is already being created, and I'm going to go ahead and highlight the mesh. Now just for the convenience purposes here, I'm going to turn off the visibility of the point data so it's easier for us to view the mesh, and there's the mesh right there. So it did a pretty good job of creating a mesh as you see it. However, the mesh does have several holes on it, so as we can tell. So let's go to the repair tab and perform a diagnostic check on it, and let's go take a look at the open edges on it. So I'm going to hit run checks, and you'll now notice that on this particular part there's over 38,000 holes or open edges found in the model. Now to fix these holes or open edges, it's going to take several man-hours to do it, manually fixing it. Now the auto fix is again a great powerful tool that'll help you fix these whole self-intersections on these meshes, like these large meshes. So I'm going to run the auto fix command in here, then select the mesh, and then right click or press enter. and I'll wait for the autofix to complete. Now this process could take anywhere from a few seconds to a few minutes depending on the number of holes to be fixed and the complexity of the geometry. While we wait on this process to complete, I'm going to go over to another example and show you some of the other powerful features that are offered in Rhino 3D Print. Now one of the features I would like to show is how well the autofix can fix self-intersections in here. So I'm going to go ahead and take this model in here. This is basically, there's two meshes. It was the inside mesh on this model. You can see that there's a self-intersection of the mesh. I'm just viewing it in the wireframe view so all of us can see the self-intersections on the mesh in here. So let me go ahead and run an autofix on this to fix the self-intersections. So I'm going to go over to the Repair tab, pick the autofix option, just grab this mesh right there, and then right-click or press Enter. You will now notice that the autofix automatically fixed those self-intersections on it. That's one of the great ways to fix self-intersections. Now let's also take a look at the stitch and close feature. So for this, I'm going to bring in another model where we'll take a look at how the stitch and close feature works. So I'm going to grab this part in here. This was basically a solid model which was converted into a mesh, and you can see that this particular part has over 400 open meshes. So just performing a join is not going to make it a closed mesh. So we're going to use this powerful feature called Stitch and Close, which is offered in the 3D Print product under the Repair tab. And in this process, I'm going to select all of the meshes, and you'll notice that it's going to stitch all of this into a closed mesh. Now, after the Stitch and Close operation is performed, if we go ahead and run a diagnostic on it, you will notice that there were no open edges identified. There you go. So the Stitch and Close is also another powerful tool to fix meshes in here. Now let's go back to the part, make sure that the autofix was completed in here. So let's go back and take a look at it. And you'll now notice that the autofix fixed all of the holes, self-intersections on this part, and now you have close to 980,000 triangles, which is close to 1 million triangles on it. Now if you perform a diagnostic on it again, you will notice that if there were any open edges detected, it'll notify you. That's great. There were no issues detected on the model again. Now, if you want to go ahead and make the mesh smaller, reduce the number of triangle count smaller to make it easier for printing, one of the tools you could use here under Inspect and Modify is Reduce Mesh. So this basically allows you to reduce the triangle count on the mesh. There's different ways you could do it. So when you do the Reduce Mesh command, you have the option to basically either reduce them by a percentage of the triangle count, or you can reduce it by a maximum deviation. So in this process, I'm going to reduce it down by 70%. So I should be looking at a triangle count on this mesh close to maybe 300,000 or less, because we currently have about close to 1 million triangles on this mesh. So this is also a very powerful tool. The mesh reduction works very well even on large models, as you see it right here. So the mesh reduction process reduced it from 1 million triangles on this mesh geometry to close to 300,000 triangles on it. This is also one of the powerful tools that's offered in the 3D Print module. Now, let's go ahead and take a look at some of the other modification tools in here. So before I do that, let me go ahead and display the mesh wires, or display the triangles on this model. You can see that the triangles on the mesh are not uniform. So to make it easier for printing, we have a nice tool called Remesh. So selecting Remesh allows you to create uniform triangles on the mesh. There's different ways you can use the remeshing. So you can either use uniform or adaptive remeshing. In this particular process, I'm going to do a uniform remeshing, and I would like to remesh the entire mesh geometry I selected. The 2016 version also offers remesh on only selected areas, which we're going to take a look at on another example as well. So here I'm going to set the edge length to be 50 thousandths, and I'll set the iterations too. Since there aren't any sharp edges on this model, I'm going to leave this option as unchecked, and I'll pick Remesh. You will now notice that this process will create uniform triangles, which makes it easier for 3D printing. So there's your remesh process right there. There it is. Look at that. Very nice. You can also perform mesh smoothing on it to smoothen out areas in the mesh. So you could go back and use the smooth functionality in here, mesh smoothing, select the mesh, and again you have controls where you can smooth a specific area, or if you just want to perform the smoothing on the entire mesh, you specify the number of iterations. You can, in this particular case, I'm going to use mesh smoothing for both directions for the vertex shift, or you can do about surface or along normals and specify these constraints. Let's go ahead and perform a mesh smoothing. Now we looked at how we can apply remeshing, reduce mesh, and mesh smoothing on the entire model. Now let's take a look at how we can perform this on a specific area on a model in here. So I'm going to go back into this part in here, and we'll take a look at how we can perform the mesh smoothing on a specific area. Now before I do that, I also wanted to point out one of the powerful tools that Rhino 3D Print offers is the Boolean tools. Now I'm going to show you how powerful the Boolean tools are that are offered in Rhino 3D Print. First, I would like to create a box so I can Boolean it out from the box. And I'm going to offset this box in here in the Z. Now we have the box and we have the mold. And I'm going to use the subtract, Boolean subtract feature, pick the box, and then pick the mold. And you'll notice that in a fraction of a few seconds, the Boolean is performed, and that's the result of the Boolean. This is a very powerful tool that's also offered in 3D Print module. Now let's go ahead and focus our attention on how we can remesh, reduce mesh on specific areas, and we'll take a look at an example on how this can be done. So for that, I'm going to go ahead and take this rubber ducky model in here. Now this was basically started out with a point cloud, and then we basically did auto fixing, remeshing on the entire model. So first, I'm going to go ahead and run a check on this model in here, and let's go ahead and check for issues on the model. So I can see that there are some thin walls being represented on the model. So if I go ahead and zoom in on this part, we can go ahead and take a look at where those thin walls are. Now as you zoom in, you can see these areas on the model show thin walls. So let me go ahead and display the mesh wires on it, so you can see that there is an issue right here. There's a thin wall that's less than the thickness of 0.1, and also over here you can see there's another thin wall on the mesh. Now in order to fix this, I can go through the process of doing some reduce mesh, smoothing, and remeshing. So I'm going to go back to the Inspect and Modify tab, and the first thing I'm going to do is reduce mesh. I'll pick this mesh geometry in here, and now I can use these tools where I can select individual triangles on a mesh, or I can do like a lasso selection or a planar selection. So in this particular case, I'm going to use a radius selection in here, and I'll put in a radius of 0.5, and then I'm going to just go ahead and pick this area on the model. You'll notice that it automatically picked all of the facets on the triangle within the radius that you specified. And I would like to go ahead and reduce it down. Let's go ahead and reduce it down by 30% in here. And I'm going to change it to 30%. I can either use the slider or the spinner controls in here, and it'll perform a reduce. You'll now notice that the issue over here is fixed. Now let's go back over to the other area where we had an issue as well. So let's go back and repeat the same reduce mesh command in here. And again, I'm going to use the same radius tool and pick this area right there, and we'll perform a mesh reduction as well. Now let's also go ahead and do a remesh in this area. So I'm going to pick the mesh, again use the selection controls, and I'm going to pick this area right in here, and I'll remesh it by specifying an edge length and number of iterations and perform a remesh. So that created a nice uniform mesh as well. Let's go back and check for thin walls again on the model. So let's switch over to the 3D Print tab. I'm going to click on check, select it, and you'll now notice that there were no thin walls. So we were able to fix those thin walls by...
Uday, let me interrupt here. I just wanted to say something, a note about thin walls. You might be wondering why he's calling these areas thin walls. The way we define thin walls is if triangles are folded on themselves in a mesh, we would consider those as thin walls. As you can pretty plainly see in the model, there are a lot of folds in the model, so the triangles, adjacent triangles are folded, and so if you took a ray from one triangle and shot it through the model, and if you hit something else along the way, we would consider that as a thin wall. So even though in reality you might not think of it as a thin wall. Hope that clarifies that a bit. Thanks, Uday.
Thank you, Joe. So here's a very nice way of fixing specific areas on a mesh using the selection tools that are now offered in the 2016 version of a 3D print module. Now let's go ahead and also take a look at the part orientation feature that is also available in 2016. So if you click on part orientation and pick the mesh, and you can specify the orang angle that you would like to determine the best part orientation to minimize the orang angle. You can hit compute, and this will basically give you the best possible orientations, and it'll also show the orang area. So if you click on this orientation pull-down menu, right now we were able to see that there are a total of 4 different orientations, and selecting each orientation will also provide you with the information on the orang area on this. So you can basically select the orientation that would suit you the best based on the orang area and the orientation that you'd like to pick. So once you specify an orientation, you can hit select current orientation, and it'll basically orient the model automatically for you. Or you can even choose the other options, like you can orient it based on the minimum bounding box, or you can orient by a pick face. So these are the part orientation controls that are offered to you in the 2016 version of 3D Print.
Hey Uday, can you select a honeycomb structure instead of a thin wall?
I'd probably like to see Joe's.
Let me take that question. When we create the thin wall, we don't create any internal structures. I understand what you're asking in terms of honeycomb or any other type of lattice structures. We don't create that at this point. So that's some of the things in our enhancements that will be coming along in our next release. Thank you.
Thank you, Joe. Okay, so now let's take a look at how we can perform certain manipulations on the mesh. So one of the things I would like to show is I'm going to bring in a prismatic part in here, and we'll take a look at how we can fix certain areas, like manually modify using the manipulator. So here I got a mesh on this part, so let me go ahead and turn off the mesh wires on it. So this is basically a prismatic part, and I can use even a non-prismatic part. I'm just using this as an example here. And let's go ahead and select the manipulator command. I'm going to go ahead and pick the model. Now once I select it, I have these tools in here where I can pick a planar face. Now the previous example we noticed where we used the paint selection by a radius parameter. In this case I'm going to pick a planar face. I'm just going to go pick this face right in here. So once I have the face selected, it automatically paints the triangles on the face, and I'm going to hit place manipulator, and I'm just going to click on the face again. You'll now notice that the 3D print module displays a manipulator, very similar to what you've seen in Rhino as your gumball. And once this is basically displayed in here, I'm sorry, I actually dropped the selection, so let me go back and reselect it. And you'll notice that these controls allow you to manipulate the mesh. I can either push and pull, I can either click on it and enter in a precise value, I can also perform a rotation of this mesh in here. So you can actually use these tools to basically modify the mesh. So I have the mesh modified right there, and then I can say finish and create mesh. It automatically modifies your existing mesh. I can also do the same thing in here. So I could say run the manipulator again, go pick the geometry. I can pick a planar face. I can also pick individual triangles on it. I'm going to pick this face right there, place the manipulator on the face, and I can actually modify the geometry. So this is also a very powerful tool that's offered to you in the 2016 version of the 3D print product. So you can use the manipulator to pick individual areas on a mesh to modify it, and also those selections are offered in mesh reduction, remeshing, and also mesh smoothing. We've also added a new tool called compare, where you can compare 2 meshes by selecting the original mesh and the mesh that you want to compare with, and it shows you a result of the comparison. Now the next powerful feature we would like to go over in our 3D print module is the support generation tools. We're going to talk about that in here in just a moment, and also the G-code generation as well. So let's go ahead and take a look at a model in here. So I'm going to go ahead and bring in this bunny. And as you can see here, we have the part loaded. And we also have a printer selected, so the mesh is already oriented and also it is placed inside the printer's volume. So I'm going to go into the 3D Print tab and take a look at our new support generation tools here. So first thing I'm going to do is click on support generation, and this prompts to make a selection. So we're going to select the mesh, and in the support generation parameters, you have the options to specify your overhang angle, the maximum angle, and then you can specify the parameters like your support diameter, your distance, the sampling distance, the connector diameter, connector height, and the base diameter, base height. And if you go to the support generation tab, you have options for your support generation. What type of support would you like to create? Now let's go ahead and hit generate in here. And you will now notice that it is computing the supports based on the overhang angle and the specified parameters. Now we can take a look at the supports in the viewport. It's previewing the supports, and this would be the supports that will be created. Now since we chose the support structure as a tree, so basically it's branching out as you see it right here. Now if you change this to a straight and then hit generate, you'll see the difference in the type of supports being generated. Now let's go back to the tree structure. Let's generate it again. And now you'll notice that over here, the supports, the base connectors on the mesh are set to use the option as minimize. So it'll try to minimize to apply the connectors through the mesh. Now there's an option if you want to disallow it, you can select disallow, go back to support generation, and then when you pick generate, it is not going to have any base connectors on the mesh. So you will notice that the support generation tool offers you a variety of different controls in here. Now you can notice that the base connectors are not on the mesh. They're not allowed to be on the mesh by selecting the disallow options, or you have an option to allow it, or the default is set to minimize, which you can change it in here. Now we can also add additional points to the support in here. So you can go back in here and say you want to add a point, and I can actually go graphically pick these points on a model. So I can select additional points in here, and then when I pick generate, it'll add additional supports in these areas. Now these are very nice tools that are offered for your support generation in the 3D Print module. Starting with the 2016 version, these features would be available. So you can add and delete, also manually modify those supports. Now once you have these supports created and you're happy with the supports that have been modeled in here, you can go to the details tab, which would then provide you with information about the support structure characteristics. It shows you the total volume and then the length of the supports, and all of these are in the units that you're currently working on. So you could be working in inches, millimeters, or any units that's supported in Rhinoceros. So there are your supports. Now what can we do with these supports once they're created? So you go into the create mesh for support structures. You have options whether you want to create all of these supports and export them as a separate mesh, or would you like to have the supports united with the main mesh, which is the part geometry, or you can basically create each of these supports out as a separate mesh. So we would like to, here in this example, I'm just going to use create as a separate mesh, and then I hit create meshes. You'll notice that the support, all of the supports are part of one mesh, and the main geometry is on a separate mesh. So the supports are being created. Now if you would like to go back and actually have this support defined as part of the main mesh, you can go back to your support generation and you can choose the option to unite it with the main mesh. So let's go ahead and do that. So I'm going to go back and recreate the supports, go back into this tab and say create and unite with the part, and hit create meshes. Now the supports will be united with the mesh geometry. And there they are. So it's united. Now we have the supports created. Now let's go into the process of generating G-code. This is a new feature that's being introduced in the 2016 version, G-code generation for 3D printing. So I'm going to go into generate G-code. Now before I do a generate G-code, it's recommended that I go into my printer selection and make sure I have my printer nozzle diameter defined, set correctly in here. If you need to update it, go ahead and set the nozzle diameter, and then you'll be able to hit save and this information gets saved into your printer list. So we have the printer selected in here. Now I could go ahead and select Generate G-code, and I pick the part I would like to generate G-code for, and then press Enter. Here you have the print parameters. You have the options to specify your layer height. You can set the parameters. You have the options to specify the solid layers at the top. We have 2 layers set at the top and 2 layers set at the bottom. You can specify your density and the pattern for the toolpath, and you can go into generate, and this process will compute your toolpaths, and the toolpaths will be previewed on the graphic screen. So the computation is in progress, and you'll notice that in just a moment the toolpaths will be computed. There they are. There's your toolpath. And one of the things you could also do is view the toolpath. You can toggle the display of the toolpath visibility in here, and also view the toolpath as you go for each level. So since we put in a layer height of 0.5 millimeter in here as an example, you can see all of your toolpaths right there. You can look them up by each level, which is basically each layer in here. So once you have these toolpaths created, the next step is to post-process these. So you can click on Post, and this automatically displays your Post and Save dialog. We have a handful of posts in here at the moment, so I'm going to use the Generate G-code output format, and I can specify my output file extension. I could use .nc or whatever is the preferred extension your controller expects, and I'm going to select Post, and I'm being prompted in here if I wish to scale the toolpath to match the active printer units. The printer units could be set in inches. The part I have here is in millimeters, so if I select yes, it'll automatically scale your G-code to be the units that your printer is defined to be in. So there's your G-code right there. For the part we just programmed. Now the mesh modeling tools that are offered here in Rhino 3D Print can also be used in your CNC milling process. So you can prepare these mesh, fix the mesh, and then use it to be able to generate toolpaths in either RhinoCam or VisualCam, plugin for Rhino, which is RhinoCam, or the VisualCam, which is part of our standalone Visual CAD/CAM module. So this basically gives you an overview of the different tools that are being offered in our 3D Print 2016 module. Now I would like to switch the interface over to a standalone system so I could show you how the interface is, and the workflow looks exactly the same or very similar, except the difference is instead of running inside of Rhino, it's going to be a standalone system where you have a handful of CAD tools for your CAD modeling, and all of your 3D print tools can be found on this 3D print browser. So the workflow would be very similar in here. So I can take an example and go through the process of how to create a mesh and work with the meshes. So I'm going to use this example of a point cloud data in here, bring in a geometry. So the workflow would be very similar. You can go through the process of creating a cloud from the mesh. You specify the parameters for creating them, and you can go ahead and enter in all of your mesh creation options, and there's your mesh. As you notice here, the workflow is very similar to what you noticed in the Rhino 3D Print plugin. So the same browsers, the same tabs, the same workflow on the interface. So once you have the mesh created, we can do an auto fix in here, which automatically fixes these meshes, and then you can perform remeshing to refine the mesh to create uniform triangles, where you can specify your parameters like your edge length and the number of iterations, and there they are. So this would be a typical process in here to work with the meshes. Now you can also go ahead and specify a mesh smoothing to specific areas where you can smooth out on the entire model. So you have all of these controls and options available exactly as what you saw in Rhino 3D Print as in our standalone system as well. So this basically gives you an overview of our 3D print product, and with this I would like to go ahead and transfer this back to Anita Anand, who is a VP of Sales.
Thanks, Uday. That was a lot of information, and we got a lot of excited comments here about the new features that were added, especially the supports and the G-code generation. Now, there were some questions about adding different printers to the list of printers that we already have on our included with our product. Maybe you want to touch a little bit on that, so we can let our customers know. I was asking about the new printer list. Anyone who has other printers other than what we have on our list, how can they get their printers added to this list?
Sure, that's a great question. So if you click on the select from the 3D print tab, or if you just click on the 3D printer list in here, and it basically displays a dialog which allows you to select a 3D printer. So if the printer that you're looking for is not found on this list in here, we can add new printers to the list, and I will be able to show you where the printer data file is saved, so which would allow you to add new printers to the list. So it'll be saved in your app data folder, so which I'm going to get to that in just a moment. And you'll be able to see a folder if you go to your app data folder for Rhino 3D Print 2016, and then under the 3D printing folder, there's an XML file called 3D printers info.xml, and you can edit this with any editor. You could use Notepad or any XML editor, and in this particular case, I'm just going to use the standard Notepad in here, and this is where you'll find information about the printer. So you can basically go ahead and add a new printer, just maintain the same format. So you specify the units that your printer supports, you specify the printer's volume, which is your length, width, and the height, and you can input the nozzle information, the nozzle diameter in here. So once this XML file is updated, the next time you run the application, it'll automatically display your printer in the list of printers to select from. I hope I was able to answer your question, sir.
Thank you. And I'd also like to add that G-code generation uses our CAM G-code generator, and it can be customized quite extensively. So if you need any customization done to that, to your file, easy to get done. There's another one here that perhaps either Uday or Joe.
Anita, can I interrupt here?
Sure thing. Go ahead.
Can Uday just show the customization for people who might not be familiar with our CAM post-process generator? Is that possible, Uday?
Sure, I can do that. So the post-processor customization in our CAM is done using a built-in post-process generator. So if you go to the post options from the program tab, we have an edit option right next to the current post processor. So selecting this would bring in your post process generator interface, and you can go ahead and customize your post processor. So this is where you would enter in your macros for the start and end block, your tool chain macros, and that's how we would go about configuring the post processor in here. Is there anything additional would you like me to show, Joe?
No, that's good.
Thank
Thanks.
you.
Okay, there's another one here that maybe you can address. What are the benefits of Rhino 3D Print's Mesh Boolean tools over the Rhino's native Mesh Boolean tools?
Well, folks, that's a great question what you asked, and just to give you a quick demonstration of the tools, how powerful the Rhino 3D Prints Mesh Boolean tools are, I'm going to go back to one of these models that you may have already noticed earlier today, and I'm going to perform the Boolean using the Rhino's tool, since you already saw the Boolean that we performed using Rhino 3D Print. So first, let me go ahead and perform a stitch and close on this model in here, And once the stitch and close has been performed, I'm going to go ahead and create a mesh object so I can use that to Boolean it with. So I'm going to basically do the same thing what I did with 3D print, but in this time I'm going to use the Rhino's native mesh tools, mesh Boolean tools, to perform a Boolean operation on it. So let's go into Rhino's mesh Boolean tools. If you go up to mesh and use the mesh Boolean, and you can do a difference on it. So I'm going to pick the same box as my base mesh, and then pick the mold as my mesh to the second mesh. And when I perform the Boolean, you will notice that the result of the Boolean, what you see is probably not what you would have expected in here. Now if I go back and perform the same Boolean in here using the Boolean tools that are offered in Rhino 3D Print, you can see that the Boolean tools are more powerful, more robust, and quick. So it works great for even complex. This is one of the examples of the powerful mesh Boolean tools that are offered in Rhino 3D Print.
Okay. Joe, would you like to add anything about the printer output formats that we support?
Yeah, I think Uday can handle that pretty quickly. He can actually show it on the product, so I let him do that.
Okay.
Thank you. So if we go up to the 3D Print tab, we have this option to use export in here. So selecting export will let you export your mesh geometry either as an STL, SLA, or AMF. Now, for those of you who are running the 3D Print product on a Windows 8.1 or a Windows 10 machine, you will also notice that there will be an additional print button that's being available in the 3D Print tab. Now the system I'm running is a Windows 7, so the 3D Print button is not, the print button is not an option here. So the native Windows 8.1 and version 10 supports printing directly from your by selecting the print drivers. If you have a print driver installed, you can click the print button, and then you can basically send it out as a print job, similar to how you just send your print job out to a regular printing out your document. So we support the STL, SLA, AMF, and file formats for 3D printing. Joe, would you add anything in addition to it?
I think you pretty much covered it today. There was one other question maybe you want to address right now. It's about the supports. Alfonso wants a little bit more information on the supports that we've added. So if you just want to go through those different parameters, that'll be great. Thank you.
Sure, we'll do that. Thank you. So let's go back into the support generation. So you basically pick the mesh, and then if you look under the parameters tab, you can specify the support to be generated for the overhang angle that you wanted to determine. You specify the support options in here. You can set the support diameter, sampling distance. Now if you go into the help system, there's an extensive help in here built in which basically describes what each of these parameters are. So if you want to learn about what the connector diameters are, the sampling distance, the maximum angle, and you can read about all of this information that's built into our enhanced online help document. So you can define all of the parameters in here, and then you go into the support generation tab where you click generate, and this basically creates the supports and previews the supports in your viewport, in your graphic screen. Now once you have these supports created, if you want to add any additional supports, you can go ahead and click on add point to a support, so you can add a few additional points if you need to in specific areas if you think that you need more supports in those areas, and then go back and select generate. So this basically creates supports for the points you just added in addition to the existing supports. And then if you go to the details tab, it'll give you the information on the volume and the length for the supports that you created, and then you go to the create mesh for support structures, and you can choose from these three options if you want the supports to be united with the part, or do you want them to be as a separate mesh, or you could create separate mesh for each support tree. I hope I was able to answer your question.
Okay, I think you did they quite clearly there. Now, I have a lot of questions pouring in about pricing. And yes, I can give a little rundown on the pricing here. A commercial copy list price is $999, but we always introduce a little discount introductory offer when we have our new version releases. So we will be offering a 25% discount on that price for all the commercial copies. Now, educational copies, it is priced at $9.99 for a 5-user copy, and that too will be discounted for that introductory period at $750. Um, with lab licenses, which are the educational versions, we will also be providing a teacher's copy, a single user teacher's copy for an additional $250, which is usually $500, but we would discount that at 50% for a teacher or a professor teaching the course. Any other questions that I can cover about pricing? Joe?
Anita, you need to talk about international pricing.
Yes, yes, that's a good one there. International pricing for people attending outside of North America, you would have to talk to your local resellers. We will be working with them, offering discounts for our customers outside of the country as well. But do talk to them. You will receive similar discounts for the product through your resellers. The discount, how long will it be extended? We always have it extended for a month after the date of release. Now, the date of release of the 3D print products, we have scheduled it for November 4th. So it is really around the corner, and its release is on schedule as well. So around that time frame, we will also send out emails to everyone regarding their release. There will be obviously a press release with that. So stay tuned to our website as well. You should be able to get a lot of information from there. Uday, anything else you'd like to add? I have one question there that I think we could address as well. Apart from the pricing, I hope I've answered all questions about that. But here's a good one. Can I machine the mesh models that Rhino 3D Print produces on a CNC machine?
Absolutely. That's a very good question. Yes, you can. So once you have the mesh geometry, mesh prepared, you could go directly into our CAM modules. So if you're running it in Rhino, you could go directly into RhinoCam and generate your toolpaths using our mill module and generate 3, 4 axis or multi-axis toolpaths, and then post-process these out to your CNC machine. So the mesh tools that are offered in Rhino 3D Print are not only geared towards 3D printing applications, they can also be used for CNC machining process. Now, I have a quick example that I would probably wanted to show this over to you here, folks. So what I'm going to do here is just take a import in a file. So this is basically a architectural woodworking model in here. As you can see, this was a mesh geometry that was brought in. And if you take a look at the meshes in here, these meshes are not really ready or usable for printing or even for CNC milling process in here. So if you want to be able to mill this part, you would want to make sure the meshes are usable. So what I can do here is I'm going to use these meshes in here. You can see there's 2 meshes on the model, but they're not clean. There are several holes and several issues on it. So I'm going to do the stitch and close on these 2 meshes in here. And once I perform the stitch and close, I'm going to go ahead and use the tools that are offered in here. So I'm going to select these meshes in here, perform a stitch and close, and now the model is ready for your CNC milling applications. You may want to mill it in 3-axis or index 4-axis setup to machine the parts. So the 3D print module offers great tools for mesh modeling and mesh fixing, and it can be used either for 3D printing or for your conventional machining process.
Thank you, Uday. I think we're rolling towards the end of our presentation today. Thank you, Uday and Joe, for helping us with all the questions and running through the products for us. Thank you, everyone, for joining us this morning. The webinar, like I mentioned before, has been recorded. You will receive an email as soon as it is uploaded for viewing, and it will be through our website. We are, as usual, always available to answer questions during the week. Call us, email us, fax us if you like, Skype us. You can even chat with us. If you're outside of North America, do connect with your local reseller, or you're always welcome to write to us as well. You can write to support@mexsoft.com, sales@mexsoft.com, and we will certainly help you out. So keep in touch with us, folks. Until next time, take care.